Good evening, everyone. My name is Sam Nasser, and this is the Azure Cleveland User Group. A little bit about the group. We meet typically every second week of the month, and the meetings are free of charge and open to the public. And so it's open to everyone, regardless of a level of expertise, whether you're a hobbyist, a student, or a working professional. Everyone is welcome. We cover a variety of topics related to Azure, whether it's infrastructure as a service, platform as a service, or software as a service. You can find all the meeting information posted at meetup.com at the link listed at the bottom of the slide. As always, we'd like to give a big thank you to our sponsors, PostSharp and DevExpress, for sponsoring the post-meeting prizes, which will be given away using the eval forms. And last but not least, NIS Technologies for sponsoring the virtual meeting space. In addition, we'd like to thank Manning.com for 35% off on a selection of books with a discount code, and the link will be made available in the chat window in just a few minutes. Some general information before we get started. Please keep in mind participation is encouraged, and the only stupid question is the one not being asked. So always feel free to jump in with any questions or comments. However, when not speaking, kindly ask you to mute your microphones just to avoid any background noise. And we want to keep it casual but organized, so feel free to jump in with questions at any point in time, either in chat or verbally. And lastly, the presentation is being recorded and will be posted on YouTube in just a few days. So for tonight's feature presentation, we have Architecture for Azure Container Apps and .NET 8 by Jeffrey Palermo. Jeff is the Chief Architect for ClearMeasure. He has over 28 years of experience, and he works as an Azure DevOps expert. He's also rated in the top 7.5% at Stack Overflow, and he's also a speaker, author, podcaster, and a great business leader. And so with that, I'd like to welcome you to the Azure Cleveland User Group, Jeff. Welcome.
Oh, thank you very much. Glad to be here. Well, I'm excited to speak here again and to share this topic. It's containers have been all the rage over the last few years, but admittedly, it's been a Linux native driver because for those of us who've been developing and pushing software to Windows Server for decades, myself going back to Windows NT Server in the late 90s and the earliest versions of IIS, we didn't have the same problems that the Linux ecosystem had. Microsoft has been pretty good on compatibility, and so with the Linux native community having to recompile kernels and having dependencies stomp on each other if you put two different applications or two different pieces of software trying to run on the same server, they had to find a way to have some hard segmentation between pieces of software because all the dependencies stepped on each other. Whereas in Windows Server, it really wasn't that big of a problem. You didn't have as much pain, and so that's why the Linux native community and all the programming languages and platforms that really were Linux first, Windows maybe. That's why they clamored for a solution, and containers came out of that side of the industry. And yes, Windows containers they're kind of a thing, but they're not as interesting because there's not a big problem when running on Windows. However, when you move to the cloud and when you look at that type of runtime environment, containers promise to lower production costs while increasing deployment and operations flexibility. And with .NET 8 and the latest version of Azure, the way that Microsoft has configured containers makes a lot of sense for the regular .NET developer. It's all come together, and whereas a lot of .NET developers have kind of been on the sidelines and a wait and see kind of attitude, it really makes sense now to run your latest .NET applications in a container on Azure. And of course, the latest version of .NET is version 8, and you put .NET 8 and Azure Container Apps specifically together, you get a pretty powerful combination for operating custom applications while driving down cloud costs. So we're going to see how these fit together, and we're also going to talk about some of the rough edges. And ultimately, what I want for you is to come away knowing what architectural choices to make for your next Azure and .NET project. So just quick background so you know where I'm coming from. About 11 years ago in 2013, I started a company called ClearMeasure, and we're a full service software architecture and engineering firm that serves companies that are building business critical software projects that are using Microsoft technologies. That's my entire career. That's kind of what we do as a consulting practice. We're headquartered out of Austin, Texas, but we've have now 45 people kind of all over the United States and a few in Canada. So we live and breathe Microsoft custom software technologies. And so we're going to kind of share our learnings with Azure Container Apps. Uh, the years are ticking by, but back in 2019, I published my latest book called .NET DevOps for Azure, and you can find it from Apress. But if you would like a free electronic copy of the book, then you can go ahead and send me an email, and I'd be happy to get that to you. And Sam can kind of share my email if it's not already in the notes. And then there's some tools that we have generally on my website. You can go to clearmeasure.com/developers, and we have a methodology for custom software we call the ClearMeasure Way, and it helps make software teams more effective. So those resources are available, and I also facilitate a monthly software architecture forum, and you can go to my website clearmeasure.com/forums, and you can sign up for the next one. But it's recognizing that while developers have a lot of avenues for professional development and learning new things, people who are leading groups of developers don't have as much, and this is an avenue for that professional development. All right, let's get into our topic. So let's talk about general themes that Microsoft is targeting, because Azure Container Apps is definitely part of a strategy, and it's important to know that strategy. And the strategy is cloud native for all .NET applications. And .NET has come a long way ever since .NET 4. The transition from .NET 4 to 5 saw a break in the reliance on running on a Windows operating system only and running on kind of any operating system, starting with Linux. But now with the Maui framework, it's also running on Mac. It's running on some other esoteric ones, but really, Mac, iOS, Linux, and Windows. So really, modern .NET is kind of the write once, run anywhere platform now. And so some of the themes that go with a cloud native strategy are observability, resiliency, scalability, and manageability. And the open telemetry story is part of that observability pillar of the cloud native strategy. But Azure Container Apps uh, has a really good story to tell for resiliency and scalability in particular. So let's dive in a little bit more detail. With .NET 8, it kind of pulled together a lot of libraries that, while not specifically taking on a dependency to Azure Container Apps, just makes it very, very easy to run a containerized application and know what it's doing. And so there's quite a few libraries that are extensions, and even some of the older ones like health checks, they have revamped and brought in under the OpenTelemetry banner, and it just fits in really, really nicely. With the .NET 8 cycle, Microsoft has done a lot of work on the container images that are available for Azure Container Apps, and they've made them more secure, they've made them smaller, and they've added on tooling that makes us more productive. One of the pieces of tooling, kind of out of scope of this talk, but for the longest time, if you're going to containerize an application, you have to author a Docker file. And with the latest tooling, the standard Docker file is kind of auto-generated for you under the covers, and you don't have to mess with it anymore. So that's one thing. On the security, there is a app user, and so no longer is the root user being used by default, and the port has been changed to a non-standard port 8080, just so it's less prone for brute force attacks and whatnot. And so I'm going to go into some size improvements. We kind of take this for granted because it's very rare that we would want to create our own custom container images from default. And so Microsoft in Azure Container Apps kind of provides us with basically baseline containers to run with. And all these containers have gotten smaller. All these containers have gotten faster and more streamlined. And so that's just great progress that we benefit from right out of the gate just by using containers on Azure. Now, if you're paying attention to the Microsoft Build Conference, you've probably heard of .NET Aspire, and that is really, really interesting because now there is a Visual Studio solution and project type that is specifically geared for being built and deployed into Azure Container Apps, and it also the tooling also builds the resources in your Azure subscription automatically for you so that you don't have to author your own ARM or Bicep or Terraform scripting on your own. Now, when it comes to a complete DevOps story that's still being worked on, we are tracking it very, very closely. All the tooling for .NET Aspire does work really, really well when you are when it is attended, when you are actually running the command lines yourself and monitoring what's going on. But of course, in an automated DevOps environment, you want everything to be unattended. And there's still some rough edges for putting the .NET Aspire automation behind a Azure DevOps pipeline. Oh, I want to just put that out there. If you're looking at being an early adopter and being on the cutting edge, this is one of those times where it'll cut you a little bit and you'll bleed. So watch and see for that, but definitely plan on being able to leverage .NET Aspire for Azure Container Apps because it is a very, very strong leap forward. Besides just the tooling to automatically create all of the Azure container related resources in Azure, it gives you structured logs and metrics tracking and distributed tracing and a view of your dependencies. And I'm not going to go into Aspire a lot, but if you didn't check out the build announcements just from May, those sessions are recorded and online. So please do that because it's pretty interesting. I'll just give you a quick sneak peek. This is what the program.cs file might look like in your Aspire project, which is called app host. And it's a way in code to describe the relationships between projects and major runtime dependencies. We haven't had that type of concept in Visual Studio before. So that's just a little bit of that. Now, let's get into Azure Container Apps. And if you have never even gone into the Azure portal in your own subscription and just created an Azure Container App from scratch, even by just clicking around with the mouse, you probably want to do that just to see firsthand. But I want to talk about the concepts and the architecture of how it's put together. And so with these two diagrams, Azure Container Apps is on the left and Azure Kubernetes Service is on the right. Under the covers, Azure Container Apps is built on top of Azure Kubernetes Service. Okay. So I'm actually going to draw a little bit on this screen. I want to talk about these concepts. Okay, so with Azure Kubernetes, you have a cluster. Okay, and this is my pen with my poor drawing. All right, but I'm going to do some drawing. And you have a big concept. You have the cluster, and yes, you can think of a VMware cluster, or you can think of an IIS cluster, or you can think of a Windows file system cluster, or a SQL Server cluster. Effectively, you could have just one, but you want to have two for resiliency. So in Kubernetes, you have the concept of the cluster, and the cluster tends to have some resiliency. But logically, inside the cluster, what are you going to run besides the networking? Obviously you have some of that going on. Besides the networking, what are you going to run? You are going to run some piece of software, okay? And that is the pod. The pod is running some piece of software. So just think of a Windows service. Think of a website. You are running some piece of software, okay? All right. So in Azure Container Apps, the environment, which is right here in Azure, it's called the Azure Container Environment. Azure Container Environment. And I'm probably not going to write, but um, that is the equivalent to an Azure Kubernetes cluster. If you create an Azure Container Environment in Azure, you are effectively under the covers causing Azure to spin up a cluster for you. Now, inside of the cluster, you have um, you have this here, which effectively is a pod. Okay, this is going to be a pod, and this is also going to be a pod. So again, over here when you have a pod, you're running some piece of software. But inside a pod, you can have the current version, you can have a different version, and you're also going to have multiple versions of it running at the same time. And within a pod, you can be running one or more containers. So, and that's the same over here. A pod is running some piece of software. A pod can run two or three, pieces of software. It could run two or three services, two or three EXEs, or whatever you happen to be running. And so in Azure Container Apps, you can run more than one container. And so the networking is pretty much automatic for you. If you run more than one container inside an Azure Container App, then the networking is going to work for you. All right. So that kind of maps. That's the mapping. The Azure Container Environment is the cluster, and the Azure Container App is the pod. All right. Let me go. All right. Now, let me talk about the DevOps pipeline structure that is going to be at play when you're deploying your .NET apps to Azure Container Apps. The reason I bring this up is because the structure doesn't change a single bit between deploying your applications to IIS and SQL Server on premise, or Azure App Service and Azure SQL, or using Azure Service Bus, or web jobs, or functions, or anything. The process for your automated DevOps pipeline stays the same. And by the way, this is just the top third of our Azure DevOps poster. And you can't see it, but I'm holding up the full version of the poster. And if you want a high resolution copy of this DevOps architecture poster that you could send to a print shop and actually print it on 2 foot by 3 foot paper, then you're more than welcome to it. No, you can't read it, but this is just the top third. But the important parts is the chain of three environments. There are three unique types of environments, and you need at least one of each. You have production, and of course, you can have multiple productions, but you need at least one. Backing off from production, we need some type of manual test environment, regardless of what you call it. You could call it staging, UAT, SIT, anything like that. You can call it QA, but we need some environment where we can go on there and check that the software is doing what we want it to do, where a human can actually do that and set eyeballs on the software. Backing up from that environment type, we need an automated test environment. And you call it the test automation environment. For a three-letter acronym, I like to call it the TDD environment to just really specify that we are doing testing. These are automated tests, and it's the no humans allowed environment. There's no reason for any person to ever look at that environment with their eyeballs, because it's just being automated and data is being loaded and thrown away left and right. And the next version of the software comes from the build and is automatically deployed, automatically run the full system acceptance test. So it is purely for test automation. But you need at least one of those three types of environments. And if you need, a second manual test environment for a product manager, or a third manual test environment for some other purpose, okay, that's fine. Just you make another one. But these are the three unique types of environments that we need in an automated DevOps pipeline. And so that's what we do. The reason I highlight Octopus Deploy and Redgate on here is because, in addition to Azure DevOps, those are the two best of breed products to kind of add to the mix. Once you outgrow the deployment capabilities of Azure DevOps, in some of the complicated scenarios, you would graduate into the need for Octopus Deploy to handle some of those more complex scenarios. And same thing with SQL Server databases. When you have complex SQL Server databases, there's nobody better than Redgate to help you simplify those workflows. So I wanted to kind of share that. All right, now I want to get into the demo. A lot of demo, and you probably want to take a screenshot of this, or you can go to those URLs. There's a lot on github.com/clearmeasurelabs, and we have several versions of some templates under the name, Onion Architecture. And this latest template has a few concepts, but it's for .NET 8. For the purposes of this demo, we're going to ignore the MAUI side of the code that's in there, okay? But the back end, the back end is all Azure Container Apps, and then it's on top of a Azure SQL database. And so the GitHub repository with all the code and all of the automation is there. You can take everything. It's open source. You can use it. The dev.azure.com/clearmeasurelabs, that has been made public. That is the Azure DevOps instance with a pipeline for this particular repository, and you can look at that. And here it is. I'm going to show it to you. Show it to you very briefly, just so you get a flavor of what it looks like. So here it is. We have the, let's scroll down, Azure Pipelines YAML file. So if you were to clone this and just plug your Azure DevOps into it, you would literally have the entire pipeline. And this is a template that we use all the time, and we've actually timed it. We can go from absolutely nothing to a completely working pipeline with a skeleton version of a .NET app targeting Azure Container Apps in 2 hours. And that is configuring all of the authentication and security and the credentials and hooking it up to our Azure, or the client's Azure, the client's Azure DevOps instance, wiring everything together because the automation is already there. So there's the GitHub repository. This is the project for the build, and here we go. And so there's actually 5 builds. You can see that we have a build that we said Onion 8 from scratch, and we literally in May we timed it from scratch and we got it under 2 hours setup. So some people talk about iteration zero. You're taking a full iteration to kind of get set up where you're ready to write some code. I would contend that once you're ready to write code, in less than a day, you should be able to equip the entire team with the ability and the structure to start writing the first feature. And with this automation, we've actually got it down to 2 hours, where we can actually start writing the first feature and having the full skeleton of the application, which I'll show you what it looks like. So I'm actually going to use that one because it has all the stages. And I'm going to scroll down, and so we have our integration build. And then we have our TDD environment. We have an extra stage where we delete the TDD environment because we're creating it in Azure from scratch. And we just want to delete it to save a little bit of money. And then we have prod and UAT. And so I've done talks on DevOps automation. I don't want to spend all of our time talking about DevOps automation, but because you have all of the code, you can look into all of these and see what they do and look at the command lines. But I am going to just kind of confirm and show you that along with creating that we're using infrastructure as code, so we're creating everything from scratch in Azure, and we're creating an Azure SQL database. But after we create the database, we get our connection string, and that's the step. Then we create our container app. And so we have a file in source control called create or container environment arm.json. So we're using that, and we're creating the container app. And then after the container app is created, we actually have to go and ask Azure through the command line, what is the URL for the container app that we just created? And in this case, it was prod UI Witty Ocean, and there we go. So if I copy this, I can paste it in there. All right, and then we're going to add revision. So when I add a revision, these are the actually AZ command. These are actually the commands to set the container image to run in the Azure Container App. And then after that, we download our acceptance test package, and then we download Playwright, which is kind of replaced Selenium, and then we run Playwright. Okay, so let me go back. Oh, by the way, one other thing I want to highlight: if you don't have code coverage for your pipeline, you definitely want code coverage. Okay, that's included here. All right, so let me go back here. All right, so those are the two URLs. Now, let me talk about the application that we have that we are putting in Azure Container Apps, and I'll open up the Azure portal. Now, the skeleton of the sample app, we just you got to come up with some idea for a sample app. So I was kind of envisioning and working on a piece of software that would generate bulletins for my church, and so we called it Church Bulletin. And this is the C4 model for architecture views, and this is the system level where you have different people that would use the application, and maybe we would use it to have a digital signage application to run a screen in the front of the sanctuary or worship center, and it would show the different events that are happening at the church. Or we could also send the information to a document formatting library and print it out. Okay, so that's the system view. And if we dive into the container view in the C4 architecture model, oh, by the way, if you've never heard of the C4 architecture model, it was created and documented by a gentleman named Simon Brown. You can actually go to the archives of my podcast, the Azure DevOps podcast, and you can search for Simon Brown. I interviewed him on the podcast. It was a fascinating interview. But it's kind of a Google Maps view where you start at the system, and just like or Google Earth, You can zoom in. You start at the system view, and the next step is taking the system and zooming in, and then look at the components. And then to zoom in more, you take one of the or the containers inside the system, and you zoom into that, and then you zoom into that. So it's kind of a nesting or a recursive way to visualize the architecture. So um, inside the system, we are going to have three different pieces of software. We're going to have the database, then we're going to have the web application, the app or the app service. These are just generic terms. And then we're going to have the application that runs in the browser, which is a Blazor WebAssembly app. And of course, we envisioned added on Maui stuff, and you'll find that in the repository, but just ignore that for now. All right, so that's zooming in. If we zoom in more into the component view, into the web service that's going to basically run as a container in Azure Container Apps, then inside of it, we have effectively what maps to our Visual Studio solution structure. And we have a core project or library. Then we have our user interface, which is Blazor WebAssembly. Then our API has some web services, our data access, which talks to the database. So that's that view. And if you dig in one more, you can go to class diagrams. And in this case, we only have one class. We only have one database table that's actually been implemented, and it's just a scheduled gathering or an event where we have date, time, name, and place. But just so you know the kind of the idea or the premise of the application that we're toying with. All right, so again, these are the URLs. Let's dive into the application. And by the way, we're going to spend most of our time in the portal, but this is the Visual Studio solution for this particular application. We have UI.server, which is basically only our startup project because we factored out the web services into UI.api. You see we have some controllers there. And I'm not going to stop and talk about Blazor. That's a whole nother topic in itself. And then the WebAssembly client is right there. And we happen to have the pages in a UI.shared because that structure actually allows us to have one place for the Blazor pages and allow a WPF client and a Maui client to all have native Blazor in those client types and only have to specify the pages once. So that's an aside. That's why we structured it that way. But I'll move away from Visual Studio and just trust me that there's an application there. All right. So let's jump into what it looks like, just so you see it for the first time. And I'm going to copy, and I'm going to actually put this into the GoToMeeting chat here because sometimes it's fun for people to click on it, and it's a Blazor template, and it also has the weather forecast, which is just calling a web service with static data. And then we have no data in our database, but it's calling over and doing a select from the table, which is returning no records in this environment that we created from scratch. Okay, so now let's jump into Azure and see what this actually looks like. So in our subscription, we have some resource groups. And as we drill in, it's a best practice to make sure that you don't put more than one environment in a single resource group. Now, it's also um, my favorite to actually put production environments in a different subscription than non-production environments. It's not required, and you can do the security that you need to just using the resource group model. You can let some people access the resources in one resource group and not in another resource group, but it's just a lot more detailed and tedious to set up. It's easier to use a subscription as a security boundary, so that if you need to give just-in-time access to the on-call engineer to the production subscription and then take it away, it's a much easier security boundary to manage. So that's my favorite. But for the purposes of teaching and showing a demo, you absolutely need to make sure that every environment has its own resource group so you can reason about that. And especially when you're creating and destroying things from scratch, which, by the way, it makes no sense to use Azure Container Apps by clicking around in the portal. I'll show you what it looks like, but it makes no sense to do it. You absolutely want to use the command lines to create and destroy things. And if we have time at the end, I can show you each individual command lines. But again, you have the full Git repository, so you have absolutely every command line in the source. But we have prod and UAT. And by the way, you're probably wondering, well, where's the resource group for the TDD environment? Well, because we have a fully automated DevOps environment, we create it, we use it, we run our full system tests, and then we destroy the TDD resource group. So we're not using it for any we're not getting billed for it. That's why it's not there. All right. So you're going to need one resource group for each environment that you have, and then you need a global resource group. Inside your global resource group, you will have your Azure Container Registry. And your Azure Container Registry is going to include various repositories for applications that have been containerized. Well, guess what? For this demo, we have one application, and it is churchbulletin.ui. Now, if my church bulletin application had multiple deployed containers, then I would have multiple container repositories. But if I go into the container repository, I see multiple images and I see all the different versions that I've built. And so if I go back, I'm going to actually go to the build that has built all of these, which I believe is this one. And let's jump into here. Okay, so let's see, 1.3.112. 1.3.112. Yeah, I think we had a straggler here we haven't removed. So I can come in here and delete it if I want to clean it up. But 112, 111, 110. So we see all those builds, and I should be able to, come into the build history here. And if I was to, well, I'm going to go back to the history, but 107's there, 87's there. Let's see. Let's make sure. Yeah, we got 107, 87. There we go. So just like on a NuGet server or npm server, where if you have a library that you're publishing to NuGet, then you would be able to see all the different version numbers for that library, and effectively the name of the NuGet package creates some type of specific feed for that package. That's the concept of the Azure Container Registry repository. It is meant to be the image of a containerized application. When we say containerized application, we mean a single container. Now, it's possible for your container to be running multiple processes, and you can do that. You can have as complex of a Docker file configuration as you want, and that's perfectly fine. But when we're containerizing .NET applications, it's very, very simple to think, I'm going to have a website. Okay, I'm going to package it as a container. I'm going to give it a name. Great. And I'm going to have something different. That's okay. A different website that's just web services. Okay. I'm going to package it as a container and just do it by itself. You don't really get an advantage to packaging two things together. Or think about that if you would get into a scenario like that. And if you have an offline batch job that needs to sit there and just watch a Azure Service Bus queue for messages, if you're running in Service Bus or mass transit, then okay, it'll be a container. So if you had those three things in your Visual Studio solution, then you would end up having 3 Azure Container Registry repositories. In this demo, I've got one. And these are, and I use the tag as the version number. Okay, this is a convention. Azure really doesn't care. You can make your tag be whatever you want, But if you make the name of your deployed process the name of the repository, and then you make the tag the version number, that is a very easy mapping. And I'll give you an example. If we go to Azure Artifacts, if you have an application where you're deploying to app service, or you're not deploying to Azure Container Apps, then it's very common in Azure Artifacts, which by the way is just a NuGet server, to have the name of a particular deployable component and then a version number. Okay, and so you're effectively taking those two concepts and putting the name of the deployable component as the repository and the version number as the tag. And if you do that, everything is going to fall in place for you. Okay, so that's Azure Container Registry in the global resource group. If we go back to the resource groups, now let's go into the prod and the resource group for the production environment. Actually don't like all this space taken up. Okay, so we have quite a few things in the production environment, and some of the things I'm not going to go through here, like an availability test that kind of makes sure we're up, a log analytics workspace, application insights. So the first thing we need that is specific to this environment is we need our Kubernetes cluster. In Azure Container Apps, it is called the Container Apps environment. So think, I need a Kubernetes cluster. Now, if you're going to set that up by yourself, it's kind of complicated. Even setting up Azure Kubernetes Service, kind of complicated. But if you were to say, let me use the Microsoft Manage Azure Kubernetes Service and just, hey, can you give me a cluster? That's what a Container Apps instance is. And so this is the cluster. All right. There's a lot of things you can do. You can give it custom DNS. Dapper is a whole nother topic in and of itself that we don't have time to cover today. But inside a Container Apps environment, Kubernetes cluster, I can have as many pods as I want, or I can have as many apps as I want. If you're very familiar with Azure App Service, think of the app service environment, and then think of a particular app, or you have your app service where you select your instance size, and then a particular app service can have a good number of apps, as well as staging slots and whatnot. So it's that parent-child relationship. So we have our container app environment, and then we have our app. And notice that it was listed the same thing. I can click here, or I can click over to apps, and it's the same thing. I can click through. So if I click through into the container app, you see right there, this is the actual Azure Container App, and this is what you're going to get charged for. If you just spin up an Azure Container environment, I haven't tested it for a full month, but there's no mechanism really that I know about to even bill for it. So if you spin up an Azure Container environment and you don't add any container apps to it, then there's no mechanism for actually using up any CPU or memory, and so really there's no mechanism to get billed. So the container app is what you get charged for, and you're going to create it. You can see the application URL. That is the one that I kind of pasted in the chat, and you can see that it's connected to the logs analytics, and you can see that they've even added support for the .NET Aspire dashboard, which this is not a .NET Aspire application, so this doesn't do anything. But let me show you how we hook this up. So revisions and replicas and containers are really the two things that are going to show you something interesting. If you go to revisions and replicas, you will see that we have one container revision running. And when you redeploy the next version, you're gonna deploy a new revision. You're not gonna blow away the container app. You're gonna deploy a new revision. And that way you keep the same URLs, the same DNS, and everything like that. If I go to containers, you can see that this is bound to the Azure Container Registry that we reviewed. The image name, or the deployable container, the image name is churchbulletin.ui, and the image tag is the version number. Okay, if I was to edit and deploy in the UI, it kind of gives me the ability to edit this guy, edit the revision, and we can see that it gives me a UI where I can look at the different Azure Container Registries I have in my subscription, and I could choose another one, or choose a different subscription. I can choose the image, which the image is going to be a repository inside the Azure Container Registry, and then the tag name, and it's got to be one of the ones that are actually in the repository. But I could deploy on an instant one of the back versions, no problem. All right, and then I can modify how many CPU cores I can give it. Right now, this is running on 25% of a single core, and it's running on half a gig of memory. And then we have environment variables. This is really important with Azure Container Apps. Um, if you're used to running an app service or an IIS, you are going to be used to putting your configuration in your app settings JSON file, or for the older applications, the web.config, and that's perfectly normal. And you copy your files and you deploy, and then you poke in different settings into that file for each environment. You would copy the files, deploy to UAT, and you would modify what's in that app settings JSON file, and you go to production, and all the same files would be in all three environments except for app settings.json. When you containerize the application, that construct doesn't exist. The image is immutable. Therefore, it's going to be exactly the same set of files, the same image in every environment. You don't have the opportunity for making the app settings.json file any different from your TDD environment to the UAT environment to prod. It will be the same. So the solution for environment specific configuration is environment variables. Okay, so that's why we have them shown here. And um, the SQL Server connection string, you have manual entry and you have reference to secret. Now, for the real connection string, you would be using reference to secret, and you would configure that inside Azure. But for the purposes of just showing you and demonstrating that it's a connection string, yep, you can put whatever you want in the connection string. And then same thing with ASP.NET Core environment. You can set that to prod or development, and that's another environment variable. And so the one thing that you want to change in your .NET code is you'll want to make sure that your configuration has environment variable reading enabled, so that after it looks in the app settings JSON file and doesn't find the key you're looking for, it also looks in your environment variables to look for that key. So all of your configuration that is different per environment will need to be set as environment variables. Now, you can have plenty of stuff in an app settings JSON file as long as those are the same settings you want per environment, and as long as you know that you will not be able to modify it on the fly. If you have a workflow where sometimes you go into the Kudu console, or you poke a setting in the app settings.json file, on the fly for doing some different things, then you will need to externalize that setting as an environment variable here so that you continue to have that opportunity. Okay, so let me cancel out of that, and let me talk about scale. So let me talk about what happens when you actually change something. Actually, let's just go ahead and do it. All right, we're here, revisions and replicas, and you can kind of deploy from anywhere. If I choose a revision mode, I can change it from single to multiple. I can have multiple versions at the same time. Actually, let's do that, because if I go here, I have a few endpoints. I have health check, which is part of the open telemetry health check. And oh, not that it's underscore health check. Okay, everything's healthy. Great. But I also have version. No, that's the one without the underscore. I also have version, and yeah, and it's giving me back 1.3.112. And so let's, just for demonstration purposes, let's go ahead and change that to multi. And then once it finishes that, that's usually pretty quick. We can create a new revision, and then just like your app service where you can do some A/B testing or route half of the traffic to one version and half of traffic to the other version, you can do that here. So we'll create a new revision, and we'll just give it a name, Cleveland test, and oh, I put a space. And let's go ahead and add a container, and let's go ahead and let's give it food. And actually, I have a lot more to get to, and I'm just going off the cuff. You'll just have to trust me that that's how it works. All right. I was about to go off the cuff and just make up some stuff. It is a cool demo, but that is how you can have two containers running side by side and filter the traffic to each other. All right. So I've showed the Azure Container Registry. I've showed the container app environment and the container app itself. Okay, now let me show you what these command lines look like, because that's really important. All right, let's go to build, and actually I'm going to go to the same one, 1.3.112, the same one, so that the URLs line up and we're not confused. All right, so I'm going to go to UAT. No, to go to production, because then the URLs will line up perfectly. Okay, so if we say, yeah, add revision to container. Okay. If this container app already exists, then we are going to, the ARM is not going to recreate. It's just going to skip by. All right. I'm actually going to pull over Visual Studio, and you can see the URL, sorry, the file name containerarm.json. Let me just show you containerarm.json, where it is. It's in core, and these are all of the parameters. Okay, and you can see that the Azure Container Registry, it's kind of global. All right, the version number is not, but the container registry, and no one really needs to author ARM from scratch. But this is what it looks like if you were curious, and this is how to specify like the initial environment variables that should be put in here. The initial set of resources being a quarter of a CPU and a half a gig, and then also the rule for scaling, and a default HTTP rule, and just saying, you know what, if there's one concurrent request, then we want at least one of these guys spun up. All right. So that's what it looks like. Pull this way to the side.
Hey, Jeff, if I
And
could interrupt you for a
we're
second.
literally executing that and creating the container app. Now, when we add a revision, we are using the Azure CLI. And so
Jeff,
we are
can you
using
hear me?
yes.
Sorry to interrupt you. Just had a quick question for you. So you had mentioned that no one should start a template from scratch. What is a good way to start a template? And the reason I'm asking is because And we have a variety of expertise levels in the audience. So if you could touch
Yep.
on that momentarily.
Yeah, so there one method is by taking a template that you already have and just modifying it. And so if you were to clone this Git repository, knowing that, oh, this is a web application and I'm containerizing it in Azure Container Apps, well, you could use this ARM template and modify it. Now you could also go in the portal and anytime you create a new resource, instead of creating it with the final go button, most of the time on everyone I've seen, there's also a save the ARM template of what you would be creating in the portal. And so that's another way to do it. Now, as .NET Aspire gets more mature, it's not relying on ARM templates at all. It's relying on bicep files, which is more terse and easier to understand. Um, and in the future, and may take another year or two to get there, we should be just using just regular command lines. So they know that it's too complicated and they're working on it. But right now those two methods, either take one of these and just modify it, or use the Azure portal and start as if you're creating a resource, but right before you get to the final step where you actually create it, instead save off the ARM file that it is crafting under the covers for you. Does that help?
Yes, very much. Thank you.
Okay, so when we are going to update an Azure Container app, it's really important. You're going to create your con- container, the Azure Container environment when you decide that there needs to be, production or UAT, and you're going to create it, and it's going to live for a long time. And then you create your first Azure Container app inside of it, and it is going to live for the life of that component. Then, when you deploy a new version of that website or that web job or whatever it's doing, whatever your container image is, you're going to add a revision. That's the terminology for deploying a new version of whatever your application component is. And so these are the command lines, and I'm showing it to you inside Azure DevOps so you can see in the context of where it runs when we're actually deploying to this environment. And before we're ready to actually run the AZ command for uh, for the revision, we have to run the AZ command in order to actually log in. And you have to log in that particular terminal session. You're not just logging in one time and you're permanently logged in. So we can see on line 33 and 34, we actually have lines to AZ cloud set for Azure Cloud, and then AZ login with a service principal, a username and password that you're going to have in encrypted variables, and the actual tenant GUID. So that logs in a particular command line session. Then you can actually run an interesting command line, and you can call AZ account set, which is going to specify which subscription you want to operate on. Okay. Now you're ready to actually run a command. And so um, inside that, we're going to run our PowerShell command, which, let's see, I'll pull up in Visual Studio real quick to show you that. All right, let me, okay, here is a good example of that. We have it, and by the way, this is in the Visual Studio solution, and let me show you where it is. Well, actually, I'm pulling up this. This one's This one's actually scaling the infrastructure and modifying it. So we have AZ login with a service principal there on line 42. And then we have line 49, AZ container app update. And what we're updating is the max replicas, and we are parameterizing the CPU and parameterizing the memory. And then actually, this is also at the same time updating our SQL database. So let me see if I can find the other container app one. Bear with me. Container app in a PowerShell file. I'm sorry for not having it pulled up automatically. I wanted to show you that particular command line because we have some of these PowerShell helpers. Here's another one that specifies a command line, but you'll want to get familiar with the AZ command and the container app section within AZ. So this particular one is where we're actually looking for the URL, and we're doing a query on it. So effectively, when you're operating on an Azure Container App in your DevOps pipeline, you're calling AZ Container App and then something. Okay. All right. Let's see if I can find one more. All right, I think that's probably it. And yep. And then the rest is just VS test running some code. All right. And so if you've never played around with this, then you can go and, well, not there. The easiest way to do it is to come in here, it'll load everything, and if I didn't want that one, if I wanted to, I don't know, back up one revision, and if I wanted to, just basically hit save, and I can change scale, but I can just hit create. You know how I kind of had the 112? Well, let's look at deploying a revision. How long did it take? We're at 5 seconds now, 10 seconds. It doesn't take that long if it's not too big, but as soon as it finishes, you should be able to refresh the URL on your side and see that, wait, we're going to a different one. Go to, make sure I have the right URL, application URL. There we go, /version. And that's interesting that we literally just deployed it. Okay, what, am I in the wrong one? I'm in prod, I'm in containers. Did I select the wrong one? Let's see. Prod UI. Save. That's 111. Save. I didn't mess with any of this stuff. 111 is what I wanted. And refresh. I must be tired late in the day for not seeing it because I've done this a million times. Sam, you see what I clicked on wrong.
Always
Yep, I
happens
must be
during the
tired
live
late.
presentation.
What's that?
Sorry, I was saying it always happens during a live presentation.
It does. Okay, so now here's 111. Let's go back, make sure we're in the right URL and version. I wonder if this version thing is messed up. Well, if I go into containers, it is showing 111. So I wonder if that version 8, well, that is curious because I've done this a million times and uh, all right, I'll have to look into that. But that's effectively how you deploy a different version is you come in, you can select whatever version and then there it is. So let me open it up for questions and put back up the PowerPoint with these URLs because you definitely want these URLs to be able to dive into. And I'll see if I can go to meeting chat on my other screen. Are there any questions that we have about either the structure of Azure Container Apps or kind of how to deploy things and options? If anybody wants to unmute their microphone, you can do that too because we have the technology for it.
I was just curious. You had mentioned some really good tips regarding the subscription and having different environments and different resource groups. What
hmm
other Azure tips do you have, or DevOps tips, I should say, just off the cuff?
Um, sure. So uh, the concept of a run book is a really old concept, but the way it's been implemented is kind of changed over time. And uh, effectively, a run book is just something that is either triggered by an event or something where you do something on a schedule to maintain a particular environment. And one of the most common ones, you could say with a lot of different ones, but it's so easy with an Azure Container App, is if you were to say at night, at some particular time in the evening, when um, when all of my users have gone home. For example, if you have a K through 12 school, well, you know that the school day is pretty darn predictable. And if there's a particular application where you know during the regular school day, there's a lot of usage on it, but in the evening, maybe there's a little bit, and at night, there's absolutely no usage of the application. If it's a very predictable usage pattern, then you might have an automated runbook where at 8 p.m. in your time zone or the school's time zone, if it's a regional thing, you basically on that schedule run a command az container app, and then take the CPU down to a very minimal setting, and you scale the infrastructure. And you take the memory down to minimals, where even if somebody logs in, during the middle of the night, okay, the application works fine, but you don't have to have a lot of resources just to run the app for one or two users. And then you have another scheduled run book, maybe an hour before school is going to start the next morning, where you modify. Basically, you run the command line again and modify the CPU and the memory back up to the level that you want it to be for the school day. That is just bread and butter scenario where you are gonna you're gonna cut your runtime costs by about 2/3 just by minimizing the resources that you're consuming during your predictable periods. Now, you can rely on the auto scaling, but the auto scaling kind of has a slight delay, and especially in a school scenario, exactly when first period starts and everybody's going to start using it, and you don't want those first period users to have to swamp the system and then wait for it to catch up, even if waiting for it to catch up only takes less than a minute. If it's very predictable, you want to automate a scheduled run book and proactively scale up those resources. Now, if your usage patterns, kind of change very gradually, then the auto scaling is going to be perfect for you because it will gradually change the auto scaling, and nobody's going to notice that it's changing. you don't want to only rely on the auto scaling when you have predictable huge upsurges in usage, because if you have hundreds of people that all of a sudden start going to your application, then some group of them is going to be the unfortunate souls that have to wait for the auto scaling to actually spin up, even if it's only for a fraction of a minute. Well, you know how much you like to click on a URL and wait for it to load. People get annoyed quickly. So that pretty much everybody should be everybody with a predictable usage pattern should be using scale up and scale down runbook PowerShell scripts.
Yeah, it's very useful. Good point.
I'm trying to think what else is a slam dunk besides that. Um, Azure SQL works really, really well with Azure Container Apps. Um, I mean, and it works really well with App Service too. I think at the point where all of your applications are an Azure Container App, an Azure SQL, and Azure Service Bus, um, you're kind of realizing the full promise of platform as a service. You're not having to mess with any concept of a Windows operating system anymore. Even with App Service, one of the first questions was, what size Windows VM would you like to run these apps on? So it kind of exposed, front and center that you were still buying a full server. Whereas with Azure Container Apps, you're able to specify, CPU and memory for each one. I didn't go into this, but it could be interesting just for people to know the different things that you can add onto an Azure Container App for um, like file systems, and you can bind an Azure Container App to Azure Files. If people have used Azure Blobs or Azure Tables before, you can bind it to Azure File System so that you can have access to essentially a letter drive. So if you have a whole bunch of files and your application needs to read and write files, you can create a binding between an Azure Container App and that Azure storage service, and then your application can make use of that storage. So they've done a really good job of integrating it with the other capabilities in Azure. It's got in going forward, it's App Service used to be my kind of go-to, where if I had a choice, I'd try to make it work with App Service. Whereas now, if I have a choice, I try to make it work with Azure Container App. All right, and if that's everything, I know we're already at an hour and 20 over. I really enjoyed coming and presenting to the group. Sam, thank you so much for inviting me. I'll leave with this kind of offer or link if anyone's interested. And again, send me an email if you wanted a high resolution copy of that Azure DevOps architecture poster or a electronic copy of my .NET DevOps book. I'd be happy to send it along.
Nice. Appreciate it, Jeff. You're always willing to give the books and resources and that poster readily, so highly appreciate that.
Happy
And
to help.
again, thanks again for a great presentation. Well done as always. If you don't mind, I'm going to take back the screen just for some final concluding slides.
Mm-hmm.
All right, so if you take a look over in your chat window, you'll see that I pasted a few links. and we'll go through those in just a second. So basically, the recording will be posted on my YouTube channel in just a few short days. If you would please subscribe to get the upload notifications. And okay, I wanted to make sure that I'm still sharing. Very good. In addition, my blog where I post tech events as well as technical articles, samnasser.blogspot.com. And again, please subscribe to that to get the updates. And last but certainly not least, the feedback eval form. The link for that is in the chat, so feel free to take a moment to fill that out so we can provide Jeff with some constructive criticism. If you haven't already heard or come across devitjobs.com, this is a website specifically for developers for finding jobs, and it allows you to pinpoint specific technologies within the region that you're looking for. So if you get a chance, check out devitjobs.com, specifically for those that are in the job market. And to wrap things up, if needed, my email, I can be reached at snasser@nistechnologies.com. You can also find all my social links at linktree/samnasser. And lastly, if we're not connected on LinkedIn, I invite you to do so. And so with that, thanks again to Jeff for another great presentation. Always good to have you, and look forward to having you the next time. And thanks for everyone who attended, and we look forward to seeing you at the next meeting. So with that, good night, everyone.